Today we're going to talk about carboxylic acids. Carboxylic acids is organic acids with the carboxyl group COOH. It's a carbon atom with a double bond to an oxygen atom, like the carbonyl group we talked about in the previous lesson, and also bonded to a hydroxy group. The general formula for carboxylic acids are CnH2n plus 1 COOH. So just for clarity, this is a carbonyl group. There is a carbon with a double bond to an oxygen, and the rest of the chain is just carbons and hydrogens. A carboxyl group is a carbon with a double bond to an oxygen, and then that carbon is also bonded to an OH group. Carboxylic acids are widespread compounds, like methanoic acid is the insect stings. So if a bee stings you and it burns, that's methanoic acid. Methanoic acid because there's one carbon, and this is the structure. The molecular formula is then CH2O2, and the condensed structure is just HCOOH. Another example is ethanoic acid, which is in vinegar. There you have a carbon to your double bond oxygen and then to your OH group as usual for carboxylic acids, but with one more carbon attached. Therefore, ethanoic acids for 2 carbons. Here you have your condensed structural formula, CH3COOH. Your clue for knowing that this is a carboxylic acid. And then the molecular formula is just C2H4O2. IUPAC names for carboxylic acids. The suffix is oic acid, and then the rest of the name is determined like always. Example 1. The IUPAC name of this molecule. Here is the clue that tells you this is a carboxylic acid. Carbon, double bond oxygen with a hydroxy there. So now the first step is always to identify the functional group. That is this part that tells you this is a carboxylic acid. The next step is to find the longest carbon chain. So here you number your carbon chain. Number 1 is always the carbonyl carbon. So 1, 2, 3, 4, 5. Now you can name your carboxylic acid. You have 5 carbons, therefore pent. Un, because there is only single bonds. 1, because the carboxylic acid part is at carbon 1, oic acid. Now because the carbonyl carbon should always be number 1, you can omit that 1 and just say pentanoic acid. Example 2. Draw the structural and condensed structural formula for 2-ethyl hexanoic acid. Now the first step is to just draw your 6 carbons because there's hex telling you there's 6 carbons. Then the next step is to add your substituents. Therefore, an ethyl group at carbon 2. Now you go to carbon 2 and then you add 2 carbons there. And then you know that it is a carboxylic acid because of this part, oic acid. Therefore, at carbon 1, you need a carbon with a double bond to an oxygen and the hydroxy group. And there you have your structural formula. Now for your condensed structural formula, you look at the groups. Here is your COOH group. Then you have a CH bonded to a CH2, CH3 that you write in brackets. And then you have a CH2, CH2, CH2. There's the 3 CH2s. And then you end off with the CH3. Making sure that every carbon has 4 bonds. Example 3. Give the IUPAC name of this molecule. Now this is the condensed structural formula. So now you first have to draw the whole structure out to see how to number your carbons. There you go. There's your COOH, COOH. Then you have a CH2 and another CH2, CH2, CH2. Now you have a carbon with 3 CH3 groups. Carbon, CH3, CH3, CH3. And now you can start your naming steps. Step 1. Identify the functional group. This is a carboxylic acid. The longest carbon chain. Give it numbers. 1, 2, 3, 4, 5. Remember, number 1 is always your carbonyl carbon. Now you look at your substituents. You have a methyl at carbon 4 and another methyl at carbon 4. And then you have your IUPAC name. 4,4-dimethyl pentanoic acid. Esters. Esters are formed when an alcohol reacts with a carboxylic acid and water is removed. You need a catalyst. The catalyst is an acid. Esters have a characteristic smell like flowers or pears. And now your general formula, CnH2nO2. This is how you form an ester. You have an alcohol and a carboxylic acid. Now you add them together, removing water. So here you remove the OH and that hydrogen for the water, and you add the red and the green atoms to get to your ester. Therefore, an ester has got a carbon with double bond to an oxygen, and then like you had the OH for a carboxylic acid, now you have an oxygen bonded to another carbon chain. Very important. Now there's several uses for esters, like in cosmetics, artificial flavorants and scents, solvents and plasticizers. IUPAC names for esters. The suffix for an ester is OH. Now the rest of the name is given just like for carboxylic acids and the rest of the molecules we did previously. Example 1. Identify always your functional group. If you see a carbon double bond oxygen bonded to an oxygen with another carbon chain, you should know that this is an ester. Now, to name an ester, you break the molecule in two. The first part that you look at is the part bonded to your oxygen atom. In this case, there is 2 carbons, therefore ethyl. Then you look at the rest of your molecule and your carbonyl carbon is always number 1. So you number them 1, 2, 3, 4. That gives you bute because there's 4 carbons and because there's only single bonds, and then the end part for an ester is OH. So this molecule's name is ethyl because that's the part bonded to the oxygen, butanoate. Example 2. Draw the structural and condensed structural formula for methyl propanoate. Prop means 3 carbons. Therefore, the first step is to just draw your 3 carbons. Your next step is to add your carbonyl bond, carbon, double bond, oxygen, and your oxygen with your carbon chain to make it look like an ester. Now the methyl part in the beginning of the name is the part that needs to be bonded to that oxygen atom, which is 1 carbon, CH3. And there you have it, methyl propanoate. Now for the condensed structural formula, you have a CH3, CH2, COO, CH3. Example 3. Give the IUPAC name of this molecule. Now again, this is the condensed structural formula. So the first step is to draw the structure out so that you can see what's going on there. Therefore, you have an HCOO, which means you have a hydrogen, carbon with a double bond oxygen bonded to another oxygen, and then you have 4 CH2 groups. 1, 2, 3, 4, and a CH3 group. And this is your ester moiety. The next step is to identify your functional group. If you see a carbon double bond oxygen with another oxygen bonded to a carbon, you know this is a ester. Now you find the longest carbon chain. And you look at the part bonded to the oxygen atom, which is in this case 1, 2, 3, 4, 5 carbons. Therefore, the part in the front of the name must be pentyl. And then you number your carbonyl carbon is always number 1, therefore methanoate. Methan because it's 1 carbon, and because there's only single bonds. OH because it's an ester, and the pentyl part comes from the chain bonded to the oxygen. Thank you.